Good afternoon to you all. I am Kapil Oberoi. I am a faculty in Geoinformatics department. In this session today, we'll talk about mobile GIS and its applications. So let's see the outline what we are topics we are covering today. So we'll start with the introduction to mobile GIS, how the GIS has evolved from desktop to a mobile based approach. Second is we'll see a formal definition of mobile GIS. We'll also discuss the architecture, the client server model that mobile GIS is based on. Then we'll see some of the applications of mobile GIS. We'll also talk about some of the mobile GIS softwares both in the proprietary as well as the open source domain. We'll also see the advantages of mobile GIS, and finally we'll wrap it up with the few of the case studies related to mobile GIS. Okay, we'll talk about the introduction to mobile GIS. The proliferation of cell phones and other mobile devices has led to this field of mobile GIS, which enables the GIS for use on the mobile devices. It emerged somewhere in mid 1990s to meet the needs of the field workers, which they basically require for surveying and utility maintenance. Early mobile GIS systems were working in a disconnected mode, but with the coming up of the wireless communication reaching the grassroots levels, the mobile GIS is becoming a part of the web. Hence, we can say that the mobile GIS is now a part of the WebGIS kind of an application, and is a part of WebGIS application. Now, mobile GIS can update server with latest information from the field, which means the mobile GIS using the wireless communication as a medium can not only receive the data from it, but whatever the data the surveyor has captured on the field, he can again synchronize it back to the centralized server, maybe at some other remote location. So the web server in turn support the mobile GIS by providing the content. So instead of him taking all the content on the mobile device, the real-time information can also be fetched from the remote web GIS server, and he can use it in his mobile device. Now the mobile GIS can be used by general public just like it is being used by organization and professionals for surveying and asset kind of a mapping and maintenance activities. The consumer mapping applications that come under the gamut of location based services talks about the services offered to the user based on his location. So some of the applications like finding the nearest hotel, finding the nearest restaurant, going from one place to the navigation from one place to another, or locating your nearest friend, all come under the location based services. Now you will also agree that many tasks that can't be completed from the office, for example, the field survey, the product deliveries, the power line maintenance, even the utility troubleshooting, and more so in the emergency response, the crew needs to go to the field. So he needs to step out of the office. Now, before stepping out of the office, he required a kind of a map in his hand to facilitate the work he's going to do on the field, maybe asset inventory, inspection, or in this case, suppose the location of a gas or water pipe, so that you don't dug it at the wrong places. So all these above activities leads to a new field of GIS. So we are moving from the traditional desktop based GIS to a mobile platform called as mobile GIS. The mobile GIS definition. So mobile GIS basically refers to an integrated software hardware framework. It refers to an integrated software hardware framework for the access of geospatial data and services over the mobile devices using wireless or a wired communication. So here basically we're talking about the handheld kind of a rugged device. It can be a PDA, it can be a tablet PC, or can nowadays can also be the smartphone over which the mobile GIS applications can be deployed. Now also the form factor regarding this mobile GIS has also dropped. Earlier we used to have the pocket PC kind of thing, but now all is fit into a palm of the hand. Now talking about the mobile GIS architecture, it works on the client server model principle. On the client side, we'll have a receiver. So this can be your mobile based platform. It can be a tablet or a PDA. Having the positioning system, the positioning system can be any GNSS provider. It can be GPS, or it can also be nowadays with the coming up of IRNSS. Once the receiver is coming into the picture, this can also be used along with the installation of the mobile GIS software. Other thing is the local data, the geospatial data can also be locally cached, or it can be also be fetched on from the server side where the geospatial data is residing. It can be in the form of a vector files or a raster file, which is basically stored in a spatial database in the server side component. So the client side can also request for data, and whatever data it has captured, it can also update to the server side application. Similarly, the server side application can send or response to the request which mobile GIS receiver is invoking through the mobile based application. Now coming to the applications for mobile GIS, it can be used in various applications. It can be used in asset inventories. So basically for creating and maintaining of assets. I will be taking one case study on this asset mapping, where I will be discussing about the mobile app related to Bhuvan Panchayat, which serves the user by capturing the asset locations. Second is asset maintenance. So again, updating of asset location, condition, schedule maintenance activity, all can be done using the mobile GIS application. It can be inspection, it can also be incident reporting. So you can report a geotag kind of a incident related to any emergency, or otherwise some reporting can also be done. Further, GIS analysis and decision making. So for example, performing typical GIS operations like measurement, area, length, perimeter, geoprocessing operations, buffering, and other GIS analysis can be done on the field using this mobile GIS application. Now coming to the software side of the mobile GIS, there are softwares available both in the proprietary as well as in the open source domain. Now talking about proprietary, so we have a ESRI product called ArcGIS for a mobile. I hope the people are aware of the ArcPad, which was the initial applications that ISRI has come up for the handheld mobile GIS kind of applications. But now with the coming of the smartphone and tablets, it has also created various apps that can be used for ArcGIS for smartphones and tablets. Similarly, they also provide an SDK through which we can also create our own mobile GIS application, maybe it field based collection or location based kind of services, by using their SDK framework. Other proprietary softwares are QPAD, which is from ScanPoint Geomatics. Now it works on Windows CE platform only. Other is the TerraSync software Trimble. So that generally it comes along with the hardware, and the software component is the same. So if you purchase the Trimble product, the TerraSync software is basically used for performing the mobile GIS operations. One more proprietary software from SuperGeo is called as SuperPad. Now apart from this the mobile GIS application that they are using on the rugged device, they also have created various apps for Android platform that you can also use for carrying out the field data collections. From QGIS, we have a QField for the Android based platform. From GVSig, they have a desktop, but they also have a mobile based application. They have this mobile GVSig based mobile based applications that run on the Windows based application, but they also have one more called GVSig Mini, which can work on Android also. Next, for the Android platform, again we have a Geo Paparazzi, which allows you to take geo tag notes. You can take it also have a map viewer. You can save offline. It allows GPS interactions also. It also allows GPS track to be identified, and then it also allows the import and the export utility, all through this Android based Geo Paparazzi application. Now in the center I have put the two applications, which is a ODK, Open Data Kit, which allows you to create your own performance for going for the field based collection forms. All can be digitized, but it is only for the Android platform. Then extension of ODK is a Geo ODK, where you can also see the map, whatever data captured, you can also see it on the mapping interface. Apart from that, you can also cache your local map data. So before going to the field, the map data is already in your Android device on your SD card, and then you can use it for data collections. Now this Geo ODK also allows you to capture unlike ODK, which is a point, here you can capture the line and the polygon also. So basically you need to identify the vertex for the line, and also for a polygon you need to again identify the vertex with the first point and last point remain the same in case of a polygon. Now the URLs for all these applications, I put them in below their screenshots. Now the advantage of mobile GIS has many advantages, which is over the traditional desktop based approach. First, you can readily identify that it replaces the paper based workflow, which is quite cumbersome and bulky to carry with. Not to mention that it requires double effort on the part of the field worker, because first he need to capture the data on the paper on the field, and then he comes back to the office and again has to do a digitization process. But here using the mobile GIS based field data collection application, he can capture all this information in one go. Apart from that, he can also capture the geotag information. But in case of a paper based workflow, he need to make sure he are capturing the location using one device, maybe capturing the photograph again through another device, and then noting down all those things in a paper based system. The other advantage is the mobility. It is also available on the smartphone. So for the Android and all those applications are also available that a common people can also use. Now with the positioning technology on board the mobile GIS device, it helps to know where I am. So by knowing the location of the people, it helps in survey, navigation, emergency response and rescue, but also to find the places of interest, which comes under the category of location based info services. Now with the connection of mobile GIS with the web GIS, the mobile GIS device or application can receive the real-time information from the centralized or a distributed server, so he don't need to carry all the information on the device per se. Now let's see some of the case studies that has been done as a part in the ISRO organization. One of the application that is done using the crowdsourcing approach is called the Map the Neighborhood in Uttarakhand, or MANU for short. It was a DST based initiative where IARS, NRSC and Survey of India participated using the crowdsourcing approach. Crowdsourcing is a way of involving a common people to contribute in maybe in the geospatial data field collection in this case. So we are targeting the potential of a large number of users who can capture the data for us using the crowdsourcing, or we also call as a voluntary geographic information, the term given by Michael Goodchild. Now just to tell you about this project, you must be aware the disaster that happened in Uttarakhand in 2013. Now in order to find out the damage that has happened onto the field, mobile based application was developed. It was an Android based application which the user can carry on the field and help us to send that geotag damaged location to our centralized server on a Bhuvan platform. So simple proformas were created, and then user can select a proforma and then click on the button saying collect field data. He can collect the data as per the proforma, and through the over the internet GPRS he is able to send the data to the Bhuvan portal, and in near real time we are able to visualize on the Bhuvan platform. Now the community that helps us in these activities were HNB Garhwal University, Wadia Institute of Himalayan Geology and the Kumaon University. The whole area was divided among them, and then before going to the field we did imparted training to the students so that they know how to handle this mobile based application. We also simulated the scenarios by taking them to the field and help them to identify the different phenomena and how to capture them on the field. So basically it was done in two batches. The first batch training happened on 27 to 29 September, whereas the second batch training happened from 3rd to 5th October. Now before designing this app, the proforma for capturing the various damages on damage due to landslides proforma was created. Riverbank erosion, damage to land cover, natural resources, and also the point of interest proforma was also created to collect the data under these categories. Now these are some of the screenshots for this mobile Manu applications. As you can see, the first user need to select the damage he wants to report. Next, he click on the button called collect field data. Then once it is done, he needs to put on his GPS, and then he can click on the button called point, where he can capture the geotagged location, the current location, and he can also take the photograph, and then he can submit it as to the Bhuvan platform. Now this application also have a facility of saving the offline data in case the internet is not available, and then once the internet is available, the saved form on the SD card can also be transmitted to the Bhuvan platform. So this infograph shows the number of points collected under the various valleys, and the total of roughly around 19,000 points were collected by the students, and basically 8,000 points were roughly the points of interest. Now for the visualization on the Bhuvan, a customized applications was created where the user can select a profile. For example, he can select all the damages he want to see for due to landslide or damage to the road. He can select the period, and then the data can be downloaded either in a shape file or in the KML. Further, the verification process was also done, validation process was also done on these points to ensure that no false data comes to this portal. So basically this screenshot shows that if you can select the landslide profile and you click on a particular push pin, so this push pin represent the different what you call the incidents that has been reported of damages that has happened related to landslide. So if I click on this, the photograph that user has taken along with all the information, so now you can see that information like the profile name, the person who has captured it, the organization name, even his mobile number, and all the performer details. You can see the extent of damage, partially damaged, slope, and all those things. The other thing that I want to tell that we make the performer as simple as possible. Mostly it was drop down, so he need to select some of the options with least requirement for him to fill all the manual entry. So he need to pick it from one of the options. The other application that I want to discuss here is the Cyclone Hudhud in 2014. Again, NRSC, using the crowdsourcing based approach, created an app where common people again reported the damages caused by the severe cyclone called Hudhud. Now this Hudhud was happened somewhere in October 2015, and the cities that are affected were Visakhapatnam, East Godavari districts, Serakulam, and Vizianagaram. But the maximum damage happened in the Visakhapatnam city, where were damages reported to airports, building, houses, and telecommunications. Not to mention that lakhs of trees were uprooted. Even the traffic was also blocked because of this disruption. And then it also caused damages to the land, to the paddy and the banana crops. Now for supporting the crowdsourcing based approach, one more mobile app related to Cyclone Hudhud was also developed at NRSC and hosted on their site, which encouraged crowd to collect information from the ground and report the event there. So again, an Android-based mobile applications which encourages crowdsourcing by asking user to report events that related to disaster caused by the cyclone Hudhud. As you can see in the cluster-based approach, more than 25,000 field data plus photographs were uploaded onto the Bhuvan platform in just 3 days. Now in the below you can see some of the statistics of the various damages that were reported. So house damages, tree fallen, power related, road related, and tank and canal breaches are reported. As you can see from this figure on the screen, you can see that the application enables the user, along with tagging the incident, the damage due to this cyclone Hudhud, they can take one screenshot or photograph from their Android based mobile phone, and they can just send it to the Bhuvan portal and then can be visualized in almost near real time. The final application that I want to discuss is the Bhuvan Panchayat, the asset mapping application that is again developed. Now Bhuvan Panchayat basically provides a platform where the decision making power is given to the hand of the local municipalities. local agencies. So they can define their own criteria, and they can do the area selection, area profiling, asset mapping, even the activity they have planned they can monitor over a period of time. To support this activity, a mobile app called the Android mobile app called Bhuvan Panchayat was also created. Again, this link is also available on the Bhuvan Panchayat webpage, where you can download this app. And then you need to do a simple registration. After that, you can start capturing the asset. Again, there are different performers created for various kind of asset that you want to map. Clicking on the map asset button, you need to specify the type of asset you are capturing, and maybe in less than 30 second or 40 second you can capture one event. Again, these applications provide the facility of offline storage, and you can save the data in case you don't have the connections. So here, using this simple app, you can contribute towards asset mapping of the Bhuvan Panchayat initiative. Okay, with this I will close, and I want to thank you all for your kind attention and patient listening. Thank you very much.